This problem is from our Unit 2 practice test. It's number 12 on my students' practice test, but in case it is listed as if your number 12 is not this problem, find the one that says 7.1-6. Okay, 7.1 is when we talked about sampling distribution of sample proportion. So if you want to review the notes or the slides, look for the one that says 7.1, how sample proportions vary around the population proportion. And I did similar problems in an additional examples video. So you may also want to check that out if you are, because these are the ones, 7.1 and 7.2. These are the ones where you had, where we had a little more application problems where we had to actually use the calculator to find the probability. So if you need more review before you take your Unit 2 practice, actual exam by this Thursday, make sure you review these 7.1 and 7.2 very carefully, okay? All right, let's go back to the problem. So in an exit poll for which the sample size is 2787, all right. For these sampling distribution problems, mean is important. Not the mean, I'm sorry. Sample size is important. So when I get it, I write it down. The sample size is 2787. The sampling distribution of sample proportion voting for the incumbent has mean, let me write that down, mean of 0.415 and a standard deviation of, I'll just abbreviate SD, of 0.009. Find the interval of values within which the population proportion falls with 99.7% certainty. Now, you've seen that number before. If I give you a couple other numbers that goes with it, have you ever seen 68, 95, 99.7? Have you seen this before? Yes, you did. This is the empirical rule number, guys. We talked about in a normal distribution about 68% of the data are within one standard deviation from the mean to the right and to the left of mean. Within two standard deviation is that's where we have the 95% of the data, and that 99.7% of the data will be within 3 standard deviation from the mean. So if they want you to find what's the range that we're gonna have the 99.7% in, we just have to find the 3 standard deviation above the mean and 3 standard deviation below the mean. But the good question is that we should see, how come we get to assume normal distribution? Because nowhere in this problem mentioned normal distribution, right? But remember, on the lecture, on the videos that we went over, I kind of briefly said it almost toward the end, right before we went over these additional examples. All right, let me show you right here. Ooh, using a normal approximation of binomial model. Take a look. This part right here. If n is large enough, remember our n was 2787. That was a big number. But big enough for what? If n is large enough that the expected number of successes, n times p, and then the expected number of failures, n times q, are both at least 15, then we get to use normal approximation. So let me go back to the problem and show you what they mean by that, okay? Going back to the problem. Now, let me show you my calculator and see what kind of calculation I'm doing to see if it's okay to use normal. N is 2787. And if I multiply the mean of 0.415, I get the number 1,156. Rounded out, 1,157 are expected to vote for this, for the incumbent. And then, who's not going to vote for this? We're going to do 2787 times the Q, 1 minus 0.415. About 1630 will not vote for the incumbent. So both of these numbers that I just got are greater than what? 15. Then you get to use normal approximation. But without really checking those, with such a huge sample size, we can use normal approximation. So let's get on it. So for the 99.7% to be in this interval, what we want is put that mean 0.415 right in the middle, but you want to go 1, 2, 3 above the standard deviation. So add 3 times 0.009, and that will be your upper bound, okay? So let me do that. So the mean plus 0.415 plus 3 standard deviation above the mean. That number will be 0.442, okay? So about 99% sure. Well, I should get the other number to the left side now. Just like we got that number, let me go ahead and find the lower bound by doing 0.415 minus, but we take away 3 standard deviation from the mean, and that number is 38.8%. So 0.388. So within these two numbers, we're going to have about 99.7%. And I did 3 standard deviation above and 3 standard deviation below. So let's look at these multiple choices. A says 0.388 to 0.442. So 99.7%, just remember that's within 3 standard deviation above and below the mean, okay? All right, that's it for this problem.